Welcome back. This time round we're going to make a start on the hardware assembly of the PiDP11. Whether we get it finished in this video I'm not sure, but you'll recall in the last video we got the Raspberry Pi ready, and that was important because we used the Raspberry Pi during the build to test as we go, so we needed to get that done first. So yeah, we'll make a start on this and yeah, we'll see how we go. In preparation for the build, I've taken all of the components out of their plastic bags and sorted them into a component tray. This will make it just a whole lot easier to find the parts as I need them during the construction. Okie dokie, so the first thing to start with is the diodes, and these are of course polarity sensitive, so you need to make sure that you can see it, the black band on the diode goes to where the band is on the PCB overlay, and hopefully, yep, that fits. Hopefully that fits, and it did. So just using my little component leg bender. It's just slightly too big for this, but it's doing the job. I just have to be careful when I push them in. They sort of snap in. So I have a little quick look with the microscope with the magnifying glass. Make sure we got them all the right way around before we commit. Oh, that one's a bit. It was just a sneak up. We'll tape them down in a minute. Yep, everything's the right way around. So grab a bit of tape just to hold them down while we solder them. Just stops them falling back out when we turn the board upside down. Right, and now we can flip it and solder it. Rightio, let's just have a quick look over those, make sure they look reasonable. Make sure we didn't miss any. And there it looks a little bit light on. Where was it? Dokey. So off with the tape. Yeah, there are a few spare diodes here. Apparently that is normal for there to be a few extra of these parts in the kit. So once we're done and we know we've got everything, they'll go in my parts bin. Right, so we've done that, done the diodes. Then we've got 6 1K resistors, brown, red, yep. Right, and the 1K resistors go where exactly? So the 1K resistors, we've got 1, 2, 3. Well, that's a start, we can put those in anyway. And these aren't polarised, so it doesn't matter which way these go, but we will put them in all the same way just for neatness. So there's 6 of them. Oh, over here. They're off to the side. Right, so do we need a wider? Nope, it's the same width. Right, so that's those. a little bit of tape to tape them in. Right, so now we can solder those in. Right, and again off with the tape. Right, now we've got these. Now where do these go? Oh, they go up in here. It's this lot. And these are slightly bigger resistors, and we'll put them in orange to the right. It's the same footprint, but a bigger resistor. Right, some more of that famous tape. And we'll do some more smouldering. Right, that's got our 390s in. What to be next? GPIO connector on the back of the PCB. Right, so we need to be careful here because as it's supplied, it comes with all these extra like spaces on here, and I'm assuming they need to be there in order to provide the clearance for the Pi. Yeah, it certainly looks like it. I'm not seeing any particular notes in the instructions, but I reckon it's goes, and it has to go on the back of the board, on this here side. So it will be going like that, and then the Pi goes on top like this. So a little bit of tape, we'll give it a tack, and then we'll straighten it up. So we'll just do one in each end to get us started. On that end, and one on that end, and just push it home for a start. So now it's all the way in. Now we'll just check, make sure it's straight. You can see straight down there, that's pretty good. So now we can proceed to solder the rest of the pins. Right, and it's got the header on for the Pi. Right, so this is our socket here. There's pins are a little bit worse for wear, but we should be able to straighten those out without any major issues. And the notch being right there, I'll put that to the top. Just because the pins have been bent, they're not perfectly aligned, so we've just got to be a little bit careful putting it in. There we go, and we're in. A little bit of tape. And we'll do the same again. We'll solder a couple of pins, and then we'll just make sure it's pushed home. Right, away we go. Yeah, we've got 64 LEDs. Yeehaw. So the LEDs will be fun because they have to go into these little bases. The LED goes in the hollow end and pokes out the bottom like that. and then goes into the board, and apparently they sort of snap in. Oh, I see, no. Apparently you only put in a little bit and then you put it in. Oh, I don't know about the snap in bit, it didn't really snap, but anyway, rinse and repeat. And don't do that where they both go down the same hole. And these are polarity sensitive, so they all have to go in the right way. Okay, so the next part of the process, now that we've got all the LEDs sat in their holes, they're not actually soldered in yet, but the next part of the process is to put this jig on, which is intended, you push it on with a little bit of force, and it's intended to make sure all the LEDs are seated properly and aligned properly and just generally neat and tidy, and they should all protrude about the same amount. And with any luck, we can turn this over without that falling off. And we can make sure all of our LED legs are all facing, they're all supposed to, the long legs are supposed to face to the left, looking from the other side of the board. So from this side of the board, they should all be facing the right. So long legs to the right, yes. So they're all facing the right direction. Wait for the iron to warm up. And we can start soldering them in. Okie dokie, so that's got all the leads soldered in. And the next thing is the two rotary encoders. So these little bad boys. There's one, and another one should be in here somewhere. So yeah, those two, and we might, and as we can see, we need to straighten the pins. There was a bit of a warning in the documentation that the pins may need straightening, and they surely do. So this is the data switch, and hopefully that will just go in there. Or not. Oh, okay. The other tabs need straightening as well. See if that goes in. That one is in. The other one also needs some pins straightened. I don't know if they come from the factory like this or they just get bent in shipping. I don't know. Either way, we can straighten them. It's not a big deal. Alright. That's those two. So, we can solder them in. Magnifier, so I can see what I'm doing. Just to make sure these are pushed all the way home, and they are. Some smolder, and we can solder them in. You hear everybody on YouTube say how hard it is to work around a camera, and that's because it's hard to work around a camera. Right, and that should have us in place. And flip it back over. There's our encoders there. They're sitting up nice and straight. But the next part of the process is to connect the Raspberry Pi, and that enables us to make sure all the LEDs are working. So the Raspberry Pi just plugs in to the back of the board like so. Now, what they do note in the instructions is that we probably should put some insulation down under here. As you can see, these sockets, if it'll focus, because yeah, these sockets are sitting fairly close to some of the solder joints. So just to be safe, I'm going to pull this back off and just put some insulation under there just for the... So this is just temporary while we're testing. A bit of tape. And I've just got it's an old bit of PCB material that was used as an insulator in something else. It's got no tracks or anything on it. So we'll just sit it there and we'll tape it on. Now, just got to be careful here because we've got our rotary encoders under this end, and they're not exactly built like a not exactly built like a tank, so we've got to be careful not to break them. Anyway, so there's a bit of insulating material. Hopefully our Pi will still sit nicely on there. Indeed it does. So we plug it in, make sure our card is out, our card is in. How many times have I been caught by that? Now it'd be interesting to see if our Raspberry Pi power supply, because this is just a cheap and cheerful power supply, it'd be interesting to see if it's got enough grunt to drive the Pi and all of the LEDs. We will see. So we'll plug that in. Apparently when it boots, we can expect to see all the LEDs come on, assuming that it's going to boot, because, as I say, the voltage might be too low with the extra load. Oh, there we go. Right, so all of our LEDs have come on. Tells us one thing important, and that is that I put them all in the holes the right way and haven't got any backwards. So these apparently all come on because our lamp test switch isn't mounted. So we can do some testing apparently. I don't know if my tweezers will be enough to do this. If we short the upper two solder holes of the test switch footprint, test switch, right, the upper two. Yep, well it did say most of the LEDs will go off, and indeed they did. And yep, we do have some blinking lights, some patterns that are happening because we're not in test mode. Short our test again and enable halt. Blinking stops, and I should see the SimH command prompt. Well, I don't have a monitor plugged in, so we'll take its word for it. If I short the top two pins of the continue switch, and there we go, it's running again. Turn the two rotary encoders and check. Yep. So we're turning that one and we can see the lights cycling through. And presumably, yep, and the other one's doing the same. So, looks promising. Okay, so I think, at least electronically this far, we're all good. So we'll, I was going to say we'll power this down. I wonder how you do power it down. Like, because you're supposed to shut the Raspberry Pi down. That's just a generic thing that you do with Raspberry Pis, being a Linux machine, is you shut them down. But I'm sure there's a way to shut it down. I'm just not quite sure what it is at this point. Worst case, we hose the installation and have to reinstall the Pi, but I don't think that's going to happen. So we'll take the Pi off, and we'll take our insulated panel off. And next up, I think we're preparing the case to do some mounting. We do that apparently before we do the switches. So yeah, we'll make a start on that. So next up, for these more recent kits, we have to put these nuts on the hex spacers. This is just because the acrylic front panel on the newer kits isn't as thick as the old one. Apparently it used to be 4mm thick, and now they're 2mm thick. So we just put a spacer on. So the next step is to take the protective cover off the front panel, and that's this clear side, the protective cover we're taking off. We're not taking off this white. I don't even know that white can be removed. I think it's printed on there. So once we do this, of course, we need to be careful not to scratch the front panel. and it's off and in the bin. So this goes in here, and then these spaces, we'll just put them in gently at the moment, just to give us a bit of leeway to get the others in. Right, now that all 5 are in, we'll just give them a finger, just do that finger tight. We'll just have a bit of a, oh yeah, look at that. So that's how our panel's going to sit. So I think we can do these up a little bit now. Just use our, don't want to do them up too tight. Maybe I've got a little shifter. Again, don't want to do them up too tight, but a little shifter helps get hold of them. Okay, so we'll turn the key switch to the left, and I believe it's supposed to go in like this. So with the 2 notches facing power and lock. Now we'll come around to the back, and I've just made a little plastic washer here, and the instructions recommend doing this. And this is purely to stop the nut from scratching the front panel material when I do it up. And then we'll get this to where it's mostly there, and then we'll check the positioning on the front. Right, and we can see that our switch has rotated, so we're going to need to just loosen it a bit. Rotate it back to where it's supposed to be, about there. And now we need to basically hold it while we just do it up a little bit. Yeah, that's pretty good. Right, so now we've got our key switch installed, and it's pointing in the what I believe to be the right direction, so our keys can go in and sits like that, and we can lock it like that. I believe that is correct. Okay, so next cab off the rank is to get the key switches done, and this set of guides is supplied. There's actually 2 guides here. The bigger one goes on the bottom and helps align the switches, and the top one does much the same. And then they get cable tied together during the assembly process to try and make sure everything's aligned correctly. So we need to snap these apart, which I might even use the cutters for, because so the smaller, the one with the larger holes goes on the bottom, and the one with the smaller holes goes on top. And like written along here is the type of switch, so a red toggle in this case that we need to push, that pushes up to activate it. A toggling purple, toggling purple, toggling purple, toggling red, and so on. And it tells you exactly what sort of switch you need and which position you need it in. So that just sits there, and we don't solder any of these switches just yet. So I've already sorted my switches. So these are the momentary switches, momentary red, and I have a momentary white, and these are momentary purples, and then I have a whole bunch of toggle reds, toggle purples, that's right, and I have a whole bunch of toggle reds. So the instructions, this is a toggle red, what's this one? Toggle purple, right. So we need a toggle red in the first that pushes up, so it goes in that way. We'll just sit him in there. said, it does warn you in the instructions that you may have to adjust the spacing of these pins to get it right. It's in there. So we're just going to set it there for the moment. Next one is a toggle. So that's our keys very loosely where they need to go. So next we put this is the switch fixer they call it. This goes on top and helps us set the spacing and alignment of all of the switches. Right, so that's on. Now we've got some cable ties that were supplied here. And we need to, right, then our switch bracket down here. You need three hands here, but this bracket that goes around the switches, we need to get it up, which they say will need a bit of prying, and indeed it does. This is going to be a little bit fiddly, so I might do this a little bit off camera and come back when we're all tied together, because otherwise you're going to watch me for the next 10 minutes fumbling and probably swearing at this as I try and align it all together with only two hands. So I'll be back in a minute. Okie dokie, so we've got the key switches in. That's the bottom plate there with the larger holes. That will get pushed back down when we're done. And this is the switch fixer at the top, which is just fixing the tops of the switches into position. Yeah, and it's just cable tied together to sandwich it together. I'm using different cable ties to the one that's supplied because I actually made a minor boo-boo. I put the cable ties in straight like they are here, and that causes the thinner ties that were supplied with it to get a bit of a wedgie up between the key switches, which sort of spaces them a little bit. The instructions do actually cover that. I just missed it. So I've redone it using cable ties that I already had, but they're wider and they don't go up between the key switches like the smaller ones do. So this is pretty much ready to start soldering. I'm pretty sure I've got all the right switches in all the right places. They're aligned okay, and I've given it I've sat it on the bench like this and just given it a bit of a push down and run along between the pins and pushed it down to make sure they're all seated properly. And I've run along the key switches, which is hard to see on the camera, but I've run along the key switches and they're all relatively straight. There's a little bit of wiggle room left, or up and down, but that's because there's wiggle room in the bracket. So that's not too big of a concern. So at this point, the instructions recommend taking a break. As it says, it matters ever so much. And my wife wants to go to the supermarket, so it seems like an ideal window of opportunity to take a break. We're back, and at this point, we're just going to run some solder along the center pins of the switches. The documentation does note that the switches will overheat if you try and solder all the pins at once. So we will heed that advice and we will not solder them all at once. And it's not hard to see why they suggest doing them, one contact at a time on the switches, because these switch terminals are pretty big, the pads are pretty big, and they take a fair amount of heat. Okay, so key switches are all soldered in, and we can now remove our tape. The tape was there just holding the end switches in. And now we can cut our ties. And carefully remove those. Remove that one. That one. Now this comes off. This is only there for the assembly process. And then we have our switches. Now this lower plate here, we may need to push it down more towards the bottom if it gets in the way of toggle, like that one. That one there, see, it's interfering with toggling our switch. So it needs to be pushed down towards the bottom again. Won't be an issue, well, at least the bottom side of it won't be an issue for the switches that toggle up, but it might be an issue on the top side. Push it down. So that it doesn't interfere with our toggle switches. Doesn't need to go all the way down, just enough to clear the switches. I think we're going to need to take this off in order to get to the, we need to take that off to get to the screw holes for the Pi. One. So I'm starting with the two that are furthest away from the I/O connector, and then we can probably just pick one. I don't think it really matters. We'll pick the one near the Raspberry Pi's ports, just in case it needs a bit more mechanical. That's interesting. Oh, actually, before we put our Pi back on, I cut a little bit of this insulating material just to sit in there. Okay, I'm not a fan of hot snot, but it's what I've got. While we wait for that, we can put our little screws on here. These are the little nylon nuts. Because these are just nylon, we don't want to do them up very tight. Okay, the hot snot's running, so before we make a mess on the bench, let's just a little bit of goop there, a little bit of goop here, and that will probably do it. Right, our little block is hot snotted in, stop it falling out of there. That's again just insulating the casing of the USB ports from the circuit board. Now we can put our LED guard back on, like a little guard, whatever you want to call it. Right, that's back on. Now these go on like this, and these nuts are just spacers. So we don't want to do them up too tight because otherwise they'll cause us grief when we go to do them up. because these threads are going to go into the hex spaces in the case itself. And we've got one down here. Watch me drop this nut on the floor and never be able to find it again. Or not. And then this one. Right, and instructions say to undo these nuts so there's about 1 millimetre of space. Right, so those are done. Now we should be able to put this in here. Like this. Now if we're lucky, that one's gone in, that one's gone in, that one's in, that one's in, and that one's in. And we can just do them up, don't have to do them up too far. Right, and eagle-eyed people amongst you will have noticed the key switch isn't connected to anything. There's a couple of things that can be used for. You can use it for switching the power to the unit as a whole, but that means the Raspberry Pi has a bit of an unclean shutdown when you do that. Or there's a soft power on and off option, which when you turn the switch to off, sends a shutdown command to the Raspberry Pi. And there's other things you can do here, like this RS-232 ports. You can populate some Max 232s there and get some actual RS-232 ports, or you can do it with USB adapters, or all sorts of things you can do. And I will probably do some of them, but for the immediate future, I'm just going to test this and make sure it actually works before I start messing with it. At least then if I make a modification to it and it doesn't work afterwards, at least I know it was the modification that broke it, and not that it never actually worked in the first place. So, one last thing I guess to do is to put the back panel on. So this, I believe, goes on, just make sure our card is in. Yes, it is. Oh, and we're going to have to put power into the Pi before we close the case up, because, well, if we don't, we won't be able to. Okay, so I have my genuine Raspberry Pi power supply. I'm not sure whether, of course it doesn't fit in through the hole that I just popped out, so hopefully that'll weaken it enough. I can just push it like that, out like that. Right, so now our power cable can go. So now our power cable can go in through there, just, and it can plug it into our Raspberry Pi, like that. And we can have to do something better about that later, but for now that will do. Now we can put our lid on. So we've got cutouts here for actual RS-232 ports, for some USB ports. I think that's for a 5 volt, like 2.1mm barrel jack type power connector, if you want to go that way. For the moment, I just want to get it finished and confirm that it works. And yeah, we can go from there. We don't need to do these up stupidly tight, they're just into plastic, so there's no benefit in doing them up tight, and you just risk breaking them. Right. There is we've got one key switch that's sitting up just a little bit. Of course there is, but that's okay. So now it looks quite nice. We've got to put some knobs on. Little grub screws in them, so I need a little screwdriver to nip them up with. Not too big. No, that'll be all right. And as with everything, we don't need to do it up stupidly tight. That's that one. And our other one. Right, and they're on as well. We put our key in the front. Now, noting that this key does nothing at the moment because the key switch is not connected. I'll give it some power. And it should, got to wait for the Raspberry Pi to boot up. And we should have a pretty looking PiDP11. I have to confess I have no idea, other than cycling here, what this is actually doing. Going to need to read the manual on the software side of it, but I think if I push this white button up I should get a lamp test. Yep. We're in enable mode, we can go halt, and we should be halted. Continue, and we run. So I think if we go halt, yeah, our run light goes out, and if we continue, then our run light comes back on again. Right, so the way we shut this down is we press the halt key down and we press the address switch. And we wait 10 or 15 seconds for the Raspberry Pi to shut down, and then we can turn it off. Simple as. Well, that's got our PiDP11 built. Looks to be working from what I can tell at the moment. Next time we look at this machine, I expect we'll be looking at the software and the operating systems that come with it, and possibly looking at some hardware, not modifications, but hardware extensions, I guess. We might look at adding some serial ports and what have you for that sort of more accurate experience. I don't have any VT100 or even VT220 or 320 terminals. I did years ago, but they've long gone, unfortunately. But yeah, so we'll probably look at some serial ports and what have you, and go from there. But yeah, until next time, if you like what you saw, feel free to tap that like button. If you've got any comments on things you'd like to see me do or things you think I could have done better, feel free to drop them in the comments below. Subscribe if that's your thing, and yep, we'll see you next time. Cheers.